Direct current and alternating current. Two ways that electricity works. But because there are two ways that electricity works, it can lead to some confusion as to how each one actually functions, and while one of them might be understandable, the other might not be so much. Before we begin, we have to figure out what exactly we mean by electricity. To do this, we separate the idea of electricity into two categories: electric current and electric energy. Electric current is the movement of electrons. Electric energy, on the other hand, is the energy that each electron has. Electrons are somewhat comparable to children, and not because they are negative. For instance, if a child is running quickly, then you could say it has more current than if it were just walking. Or if there are many children running, that has more current than just one child running. Energy is similar to how much a child wants to move. And just because it does have a lot of energy does not mean that it is actually capable of moving. So, what are the similarities and differences of DC and AC in terms of current? Of the two, direct current is oftentimes the one more well understood and seemingly just more logical. That is because, in a circuit like this, electrons that are in the circuit will just go around and around, typically until the battery dies. It is worthwhile to note right now that both a resistance and an energy input are required in a circuit like this. The energy input does what it says. It puts energy into the circuit. But what the resistance does is make the electrons give up their energy, so that they are always giving up as much energy as they are being given. Because we all know that constantly giving energy to something without letting it get rid of that energy can be a very bad thing. On the other hand, with alternating current, the electrons in a cable, for instance a power line between your house and a power plant, will move a very short distance, then return to where they started, then they'll go backward a little, then they'll move to where they originally started again, then forward and backward, and so on and so forth, similar to what this wave depicts. A better way to describe what the electrons are doing is to say that they are vibrating, not moving, and this has a chain effect, so that when one electron vibrates, it makes other electrons vibrate as well. This gives rise to several questions. How does alternating current transmit electricity if the electrons never move? Don't electrons in direct current run out of electricity? And many other questions. Thankfully for us, these are questions that electric energy is capable of answering. In direct current, electrons in the circuit will start here with lots of energy. They want to move to where there is no energy. To do this, they start going along this path and will have loads, such as lights, heaters, or whatever is plugged into your power source, that will decrease the amount of energy that they have. A circuit can have multiple loads to decrease the energy of the electrons several times. After the electrons have left all the loads and have no more energy, they will then go into a battery that will give them more energy, the same amount of energy as when they started out. In alternating current, an electron will have lots of energy, like the ones in this diagram denoted by filled arrows pointing up. Electrons with empty arrows pointing down have a below average amount of energy, and the electrons with a line have the average amount. So then electrons with much energy will give all their energy to the next electron beside it, and that electron will give its energy to the electron beside that one. Like a game of hot potato, they just keep on passing the energy until it gets to the end. This is why they vibrate, because while they are vibrating, they are passing the energy from one electron to the next. So electrons are giving and being given energy rather quickly, but in the end each electron will finish where it started. Also, there will always be a power source, such as a generator or a power station, to input energy into the cable. Another good way to compare alternating and direct current is to think of alternating current like waves on the beach. The individual water drops never move closer to the shore, but the energy transmitted by the water drops, in the form of a wave, does, just as electrons never move closer or farther away from your house in the power cables when they transmit electric energy to your house. And with direct current, it is more like a stream or river, which has a constant movement of both water and energy, just as electrons are continuously moving and transmitting energy in a DC circuit. We see that alternating current and direct current do the same job, just in a different way. The goal of each is to get electric energy from point A to point B. Alternating current will have electrons take energy from point A, pass the energy from electron to electron, until the energy gets to point B. But direct current, each electron will take energy from point A, and travel with the energy they have and give the energy away by the time they get to point B all by themselves. These are the similarities and differences between direct current and alternating current.